The dimensioned physical constants, such as the speed of light, the strength of gravity, the mass of the electron, are believed to be both universal in nature and have constant value in time. They form the scaffolding around which the theories of physics are erected, and they define the fabric of our universe. But science has no idea why they take the special numerical values that they do, for these constants follow no discernible pattern. As they cannot be derived from other constants, they are often referred to as fundamental constants. These constants are measures of units such as mass, length, time, and charge, and so these units must also be independent of each other. We cannot, for example, measure the distance between London and Tokyo using amperes and kilograms, for these units are somehow different to meters and seconds. This is predicated upon the assumption that somehow mass is, time is, length is, and this gives the universe itself a physicalness as opposed to a computer simulation. However, there are anomalies to these constants which suggest a mathematical relationship between these units, and this relationship is assigned here a unit number, this unit number defining the relationship between the units. In this table, we see the unit number and its SI unit equivalent. The constants can then be written as in this table with the unit number in the right column. The Planck constants are direct measures of these units. Planck mass is measured in kilograms, Planck time in seconds, and so on. But as these Planck constants are measures of units, we have to find substructures from which they can be built, but which are unitless. Typically, numerical values are assigned. We can set the speed of light as 1 and so on. But this gives us no useful information. And so here are assigned geometrical objects instead. We may then construct complex objects, Lego style. For example, by combining the object for length, the object for time, we can construct a new object, velocity v. However, this geometrical approach would require that the objects are not independent of each other, and so a unit number relationship hypothesis can be tested. In Table 2 are listed the geometrical objects. They are the geometry of two dimensionless constants, this alpha, the fine structure constant, and this omega. Because alpha and omega have numerical values, these objects can also have numerical values. And so we can convert from them to our numerical values by using scalars. Here we take scalar v and use it to convert the object v to the speed of light c. Object v is dimensionless, and so by changing the value and units for scalar v, we can convert to any system of units, whether SI or imperial or whatever. Because the scalars have units such as meters per second, they also follow the unit number rule, and so we find that we only need two scalars to define the rest. In other words, once we know two constants, then we know two scalars, and so we know all scalars, and so can solve the other constants. In this example, we use scalars v and r. Here we use three variables, x, y, and I. The unit number for x is 1. It is our base unit and could be described as the square root of velocity over mass. Y is a ratio of scalars and has a unit number 0, as does I, which is simply omega to the power of 15. We can now build a table of the physical constants in terms of x, y, and I. This gives a complete unit number table with the theoretical relationships between the units. Here is the unit number theta, and we simply take x, which is the base unit, to the power of theta. In this table, we calculate the constants using our alpha-omega geometrical objects and the two scalars v and r, and compare with the codata values on the left. The numerical values match, and so too do the unit numbers. In this section, we find combinations of the scalars whereby they cancel, and this means that with the scalars gone, these combinations of the constants are reduced to those geometrical object equivalents. The first column, which lists the numerical values for our constants, is the second column, which are the geometrical objects. This will apply to any set of units, even those used by aliens for their constants, although using alien numbers, are still constructs of the geometrical objects and the alien scalars. Take away the scalars, and we are left once again with these geometrical objects. And as these objects are the geometry of alpha and omega, we only need these two dimensionless numbers to solve that first column for any set of units, human or alien. In this table, we find combinations which break down to alpha. The first formula is well known. We replace the constants with their geometrical object equivalents and are left with alpha. The other combinations listed in the table likewise also reduce to alpha. As in the above, these combinations are dimensionless and have no scalars. Here we find a combination that gives us a formula for the electron. We take magnetic monopoles Al and combine with time t. The result is a dimensionless formula, this Fe, also with no units and no scalars. We then combine this Fe with the Planck units to get the electron parameters of wavelength, mass, charge. This means that although the electron has dimension parameters, the electron itself, which is this formula Fe, is a mathematical particle, not a physical particle. There are three constants whose values are known with high precision. We can arrange them so that the unit number and scalars match the less precise known constants, and then use them to solve these constants. How this works is shown here with Planck's constant. In order for the dimensioned physical constants to be fundamental, as noted above, the units must be independent of each other. There cannot be any unit number relationship. However, these anomalies question this fundamental assumption. In every combination predicted by the model, they give an answer consistent with core data. Statistically, therefore, can these anomalies be dismissed as coincidence?